Alright, this is for lesson 6 involving solving quadratics. Okay, but we're going to solve quadratics by a special method, and this only applies for special circumstances. Okay, remember the standard form for a quadratic equation is ax squared plus bx plus c equals 0, with one caution that a does not equal 0. And what that forces us to always have is a quadratic term, a term with an x squared in it. But notice it doesn't say anything about b or c being 0. Okay? One special case is if the b value equals 0, in which case the general form looks like this. We don't have that linear term, the x term, in the middle. Okay? So if you'd like to see numbers, problems like this, oops, not C, we want to put some numbers in there, I said. So let's put in a 5. Or problems like, x squared minus 6 equals 0. These are types of problems that are special cases of quadratics that can be solved by another method other than factoring, and that's by taking square roots. So we're going to look at one that can be solved by both methods very easily. So let's look at this quadratic, x squared minus 16 equals 0. Okay? Note it doesn't have an x term in it, but it is still quadratic. If I wanted to solve this by factoring, I would notice it's a difference of squares, and I could factor it. It would be plus 4 and minus 4, and therefore x equals negative 4, or x equals positive 4. Those are my two solutions. However, because it doesn't have a b term, it can be solved in an easier fashion. That's by isolating the x squared, getting the x squared by itself, and then square rooting both sides. When I square root both sides, I get plus or minus in whatever the square root of that side is, in this case 4. So this means again that x equals 4 or x equals negative 4. We just write it with this abbreviated plus minus because it's shorter. And so here I've solved it by taking the square root of both sides, and over here I've solved by factoring. Now which one's easier kind of depends on you as an individual. However, I will guarantee that this method of square rooting both sides is very powerful and should be used in certain cases expressly. Let's look at one of those. Let's say I've got x squared minus 5 equals 0. In this case, I could try to factor it. However, 5 is not a perfect square, so it will not factor. However, if I notice that it does not have a b term, I can take the 5 to the other side. I can now square root both sides. I get x equals plus or minus, and I just leave my answer as the square root of 5. That means x is either positive square root of 5 or x is negative square root of 5. Let's briefly discuss why we always get that plus or minus, so you understand why that's true. We'll look at a simpler example. We'll say x squared equals 4. When I square root both sides, our first inclination is just to square root the 4 and say our answer is 2. However, we need to look at what the equation is asking. In this case, it's saying, what can I square that gives me 4? Well, there's two answers to that. 2 squared gives me 4, and negative 2 squared gives me 4. And because that's true, and always is true, when we square root both sides, it's just easiest to say plus or minus of whatever the square root of that number is, in this case 2. So we always give both answers because squaring a negative gives me a positive, and squaring a positive gives me a positive, in this case 4. Let's look at one more variation on this that can be kind of tough. Let's say I've got 4x squared plus 20 equals 0. Again, I would notice there's no b term, no x linear term, and so I know I can employ square roots to solve it. Again, I would take the, let's make this minus 20. That way we won't have to deal with something we're not ready for. I'll take the 20 to the other side, making it positive 20. Okay? Now, I could square root both sides, but it's a little awkward to square root. At that point, I would instead divide both sides by 4. 20 divided by 4 is 5. And now I would square root both sides. So get that x squared alone before you square root both sides, and you'll have much more success. And finally, a really tricky one. Let's use 9 this time on the right side. Okay. This one's written in kind of a strange form. Notice we have x minus 2 squared equals 9. There's a couple of ways to solve it, but the method I would employ for this is I would notice that over here I have a perfect square. And it's not just that it's a perfect square, it's got the x inside of it. And because of that, to get that x out of it, I can square root both sides. Now this square root, remember, has a little 2 there, so square rooting it just gets rid of these squared. On the right side, I've square rooted both sides of an equation, so I get plus or minus 3. Now I take my 2 to the other side. My answer is x plus or minus, or is 2 plus or minus 3. Now this does represent two answers. It represents 2 plus 3, which is 5, and 2 minus 3, which is negative 1. This is a much simpler method than what I would call the brute force method. And the brute force method looks like this. That would be to square the binomial. When I square it, I'm going to have to FOIL it together, and I get the following trinomial. Then I'd have to get it equal to 0. Then I'd have to factor it. Then I'd have to set each factor equal to 0 to get the same solutions. So either method works, however the one on the left is a much quicker method. And I do that when I notice I've got that perfect square on the left-hand side and just some number, some constant on the right-hand side. I can free up that x and solve for him very quickly.